Right, so I just gave you all the formula sheet that you're going to be using for this unit. There's stuff in there for all three chapters. That first page will be stuff that we'll be doing for the first two chapters. And then on the back, there's stuff on trigonometry. There's also on the back some of the other stuff that we've learned about already in this course. So this is the formula sheet that you're going to get not only for your quizzes and tests for this chapter and unit, but also for the final exam. This is the formula sheet that you will get for the final exam as well. Okay, so I'm giving it to you now so you can start working with it, using it, so that you've seen it prior to the final exam. If you look at the top there is some metric stuff. Relationship between common SI, that stands for System International, that's the metric system. The fact that 1 kilometer is 1,000 meters, 1 meter is 100 centimeters, and 1 centimeter is 10 millimeters. So there's some of the relationships. We also looked at that metric staircase yesterday that can be used. So if you're going to use that, though, you have to be able to reproduce that on your own. Then you can see there's also a relationship between common imperial units, which is what we're going to talk about today. And then we'll also get to converting between the two, between metric and imperial. So that's the last column at the top of that page. All right, but let's first talk about the imperial system. So we're asked to use the ruler to measure the diameter of this standard CD. And this ruler is in inches. It says right on there that it is inches. So we can move the ruler. So if we go right through the center with the very bottom of the ruler, that bottom line, which represents 0 as you're counting up here. So here's one thing that's quite a bit different than the metric system. Remember when we looked at that metric ruler yesterday? We had a centimeter ruler, but then in between each centimeter, they were divided up into millimeters. Between each centimeter mark, there were 10 segments in there, which represented 1 millimeter, because there are 10 millimeters in a centimeter. The imperial system is different. It's not in increments of 10. In fact, if you go from 0 and you count how many lines there are, and we notice that they're of different lengths, these lines, but if you count them all, you will see that there are 16 lines between 0 and 1. So therefore, each of these lines stands for one of those 16s, 1/16. That's normally the smallest increment that is used for measuring on an imperial ruler or a measuring tape. But to know for sure, you have to physically count how many increments are there between, let's say, 0 and 1 inch. So if we do it, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Each increment is a 16th of an inch. So we will use that to measure the diameter in inches. Starting at the bottom, we're going to 1 inch, 2 inch, 3 inch, 4 inch, and then it ends below 5 inches. So we'll have to count how many of those increments above 4 inches this measurement goes. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 it looks like. 11 of those increments from 4 to get to the top of that CD. So that would be 11/16. That's the diameter in inches. 4 and 11/16 of an inch. Now again, if you were using what's on your page, the scale's different, you might get a different answer. If you took a ruler and you measured the CD case on your page, you'd probably get a different answer, because it's a different scale. It looks different on the board than it does on your page, right? But using that, the diameter is 14 and 11/16. Now, the radius is half the diameter. So we can figure out what the radius is by taking the diameter and dividing by 2. So what we would want to do in this case is we want to change that improper fraction, or that mixed number, I should say, into an improper fraction. So we talked about this at the start of the semester. To do that, you're going to take the bottom number, you're going to multiply by 4. That's going to give you 16 times 4, which is 64, plus the top number, which is 75. And you keep the same denominator. So 4 and 11/16 is the same as 75 over 16. And you could check that on your calculator. If you go 4 plus, and then in brackets, 11 divided by 16, it gives you that decimal. If you go 75 over 16, which is what we got for an improper fraction, same decimal. That just shows us that our improper fraction is correct. Now, instead of dividing by 2 over 1, we can multiply by the reciprocal. We can multiply by a half. That's how we divide with fractions. We multiply by the reciprocal. And so now, because it's times, and we multiply top times top over bottom times bottom. So on the bottom, 16 times 2 is 32. And 75 divided by 32 gives us that number. On my calculator, if I go math, enter, enter, I think it'll turn it to a fraction. Yeah, it did, but it was the improper, and that's fine. We can leave it like that. 75 over 32 inches. You could also change it to a mixed number if you wanted to. 32 goes into 75 twice, which is 64. And then you need another 11 to get up to 75. So 2 and 11/32 of an inch. There are some imperial measuring devices that will measure up to the nearest 32nd. This ruler is 1/16 of an inch because that's how many increments there are between 0 and 1. I'll get you 1 second. But there are some that will actually have 32 increments between 0 and 1. They're measuring to the nearest 32nd of an inch. Yes, Kai? I can't hear you. 4 and 11/16 up here. This one here, 4 and 11/16. Pardon me? Are you talking about when I counted up here? I don't know what you mean. 4 and 11/16. I understand. You're saying the 11 looks like a 4. Okay, it's an 11 over 16. Sorry, I didn't understand what you were asking. Okay, so that's an introduction into the imperial system. The smallest increment, or the smallest measurement we use in the imperial system, is an inch, right? And so an inch is actually, if you look on your conversion on the formula sheet I just gave you, it's a little over 2.5 centimeters long. That's an inch, okay? 2.5 centimeters long, approximately, is an inch. That's the very first conversion on that formula sheet on the front page, top right. So, most of the world, we talked about this yesterday, uses the metric system, but the United States still uses the imperial system for linear measurement. It is based on the older English units of measurement derived from nature and everyday activities. Okay? So the inch is the smallest increment that we use. The next one we're going to see is a foot. You've heard that term before. And actually that length for a foot actually came from the King of England at the time that this was all developed. They actually used his foot to determine how long a foot would be. So that's why it's called the foot. But they used the king's foot size for that distance, for that length. So we're going to talk about reference for linear measurements like we did yesterday, and we'll do some problem solving as well. So again, this imperial system is a system measurement based on British units, and it is still used in the United States. So on the next page, we'll talk about some of these other ones. We've already talked about the inch. The symbol for inch is just IN, or 2 tick marks represents inches. Then we have a foot, and the symbol can be FT for feet or 1 tick mark. And note it says here there are 12 inches in a foot, and it says that on your formula sheet that I gave you. If you look at that middle column of the formula sheet, it says that 1 foot equals 12 inches. So that's there. The next one is a yard. There are 3 feet in a yard, or 36 inches in a yard. Remember, each foot is 12 inches, so 3 feet is 36 inches. Again, that's on your formula sheet. And then the biggest one is a mile. There's 1,760 yards in a mile, or 5,280 feet in a mile. And just as a conversion, if you look at that last column, you can see that 1 mile, or 1 kilometer, I should say, is 0.6214 of a mile. Up above on the formula sheet, about halfway up, 1 mile is 1.609 kilometers approximately. Okay, so that just gives you a point of reference for comparison. And we're going to do some conversions within the imperial system. Tomorrow, we will get into converting between the two systems. Okay, so this next part just talks about a caliper. It can be used to measure really small or really fine measurements if accuracy is really important. Again, as it says there, most tape measures measure to 1/16 of an inch, which is the ruler that we saw earlier. But a caliper can actually measure to 1/1000th of an inch. So again, it would be used when accuracy is really, really important. And so this picture here kind of shows that a caliper has 2 scales, and you're not going to be tested on anything dealing with calipers. So let's move on and look at example 1. It says the photograph shows a polar bear near Churchill, Manitoba. The scale of the photograph is 1 to 24. So we talked about scale factors yesterday. This is what this is talking about. When you give the scale as a ratio, it's 2 numbers that are being compared to each other, right? So the way you need to read this is that the order is the dimension in the picture followed by the actual dimension. So what this tells us then, because the scale is 1 to 24, it means that the actual dimension is 24 times the dimension on the picture. That's what that means. So the first question asks us to calculate the height of the bear's back to the nearest inch. So we will use our ruler here, and we will measure from the bottom of his foot to the highest point of the back. Looks to be about right here. So that would be 2 1/16 of an inch. On the picture, the bear is 2 1/16 of an inch high. So we'll start with that. Because the back is 1 tick mark above 2. Each tick mark is 1/16 of an inch. We just talked about that, right? When I did the CD case, and we counted how many increments there were between 0 and 1. There were 16 little lines there, 16 increments. So each line represents 1/16 of an inch. So that is 2 1/16. That's the measurement on the picture. Now, before we'll multiply that by 24, let's convert it to an improper fraction. 16 times 2 is 32, plus 1 is 33 over 16. And our scale factor is 24, or 24 over 1. So we can multiply first, simplify after, but we can also simplify first. We can divide the 24 and the 16 both by 8. And this allows us to simplify first. 24 divided by 8 is 3. 16 divided by 8 is 2. So multiplying what's left, 33 times 3 is 99 over 2 times 1. So that is the actual height of the bear's back in inches. 99 over 2 inches, which we can write it as a mixed number. That's 49.5 inches tall. And remember, 2 little tick marks means inches. So there's the height of the bear to the nearest inch. Now it says to the nearest inch, so I guess we could say approximately 50 inches high. And now we want to find in part B the length. Only in this case it wants to give it to in feet and whole inches. But it starts with using the ruler and measuring how long that bear is in the picture. We want to go at its widest point. So from the very back of the bear right to the tip of the nose. So it's between 3 and 4 inches. So we'll count to this point right here, and maybe I'll draw it on there. There's the tip of his nose. So if we count how many 16 past 3 it takes to get to that point on the ruler, it's 1, 2, 3, 4, 5, 6, 7. 7/16 past 3. So the length of the bear in the picture is 3 7/16 of an inch. Which, if we change that to an improper fraction first, 3 times 16 is 48, plus 7 is 55 over 16. And again, our scale factor is 24. 24 over 1. We're told the scale is 1 to 24. That's what that means. It means the actual dimension is 24 times the dimensions in the picture. Once again, we can simplify first. We can divide top and bottom by 8 again and get 3 and 2, like we did before. And so now we've got 55 times 3, which I think is 165. Yeah, 165 over 2. Which, if we divide, gives us 82.5 inches. Now, this question asks us to write our answer in feet and whole inches. There are 12 inches in a foot. It says that on your formula sheet. So if you take the 82.5 and divide by 12, you get 6.875. So that's 6 whole feet plus 0.875 of a foot. 6.875 feet. Remember, 1 tick mark means feet. And I got that by dividing all the inches by 12. There's 12 inches in a foot. But we're not quite done because it says answer in feet and whole inches. Right now, we just have our answers in feet. You've got 6 feet plus 0.875 more feet. So to find out how many inches 0.875 of a foot is, we'll get rid of the 6 in front by subtracting 6. And now we'll take that decimal, it's 0.875 of a foot, and we'll multiply it by 12 because there are 12 inches in every foot. So it's 6 feet, and if we round to the nearest inch, it'll be 11 inches. Okay. It says answer in feet and whole inches, so instead of using 10.5, we rounded it to 11. So there's the actual length of the bear in feet and inches, almost 7 feet long. because remember there's 12 inches in every foot. It's just 1 inch short of 7 feet long. So on the next page, the photograph of a muskox uses a scale of 1 to 30. You're asked to calculate the height of the muskox and the distance between the tips of its horns in feet and inches. So we've got a ruler here. Just because of which way the ruler is situated, let's start with finding the distance between the tips of the horn. So it's between 1 and 2 inches. So to find out how many 16ths of an inch, it's actually only, this is 1 here, it's 1/16, 2/16. There's only 2 tick marks past 1 to get the edge of the horn to the right. So that is 1 and 2/16 of an inch wide. So this will be the distance between the horns. One and 2/16, which would reduce to 1 and 1/8 of an inch. 2/16 reduces to 1/8. And see, that's why the second increment is a little bit longer than the first. Those smallest increments, if you ever end up on one of those, it's a 16th of an inch. The next largest line, a little bit longer than the 16th, represents an eighth. And then the next largest line represents 2/8, which is a quarter. This next line represents 2/4 or a half. The next long line is 3/4, and then the longest lines represent a full inch. But the distance between the horns is 1 and 1/8 of an inch, which will be 9/8 inches if you write it as an improper fraction, which has to be multiplied by 30/1 in this case, because that's our scale factor. So before we multiply again, we can simplify. We can divide top and bottom by 2. Makes it a little simpler. And so you have 9 times 15, which is 90 plus 45. That's 135/4. And this, again, is still in inches. We use the ruler that was in inches. We multiply by our scale factor. Keeps it in inches. We can go 135 divided by 4 to get it as a decimal. 33.75 inches. And then to convert that into feet, we divide by 12, because again, there's always 12 inches in a foot. So that's 2.8125 feet. And remember, 1 tick mark represents feet. But we want to state it in feet and inches, like we did before. We can take away the 2, which leaves us with just the 0.8125 of a foot. We'll multiply that by 12 to convert that into inches. 9.75 inches, we would round to 10. So 2 feet, 10 inches. That's the distance between the horns. And now we want to do the height. So we will have to rotate our ruler. So I'm going to say that we're going to use that point right there on the ruler. I've got the bottom, the 0 part at the bottom of this hoof, going up to this point there. And it's 2 and 1, 2, 3, 4/16, or 2 1/4 inches high. on the ruler, which is 9 over 4 inches. When you convert that to an improper fraction, princess, which we need to multiply by 30 because that's our scale factor, 30 over 1. Once again, we can divide top and bottom by 2 to make it a little simpler first. And so now it's 135 over 2 inches. Above it was 135 over 4. And 135 divided by 2 is 67.5 inches. If we divide that by 12, we'll convert it into feet. 5.625 feet. And then to convert that into feet and inches, we'll get rid of the 5. It's 0.625 of a foot is what's left over. Multiply that by 12 because there's 12 inches in a foot. So 7.5 inches, we round up to 8. So we'd say 5 feet, 8 inches. So there's the height, actual height of that muskox. Again, we're using the scale factor of, in this case, 1 to 30. All right, let's look at this one. The Carsons wish to buy a 32-inch TV. Both of these TVs are 32 inches, but the size is measured across the screen diagonally. You see, the diagonal is always going to be a larger number than the two actual sides of the TV, because really you've got a right triangle here. Right? If you take, let's say, those two legs of a triangle, the hypotenuse is always the longest side. So it is a little bit, I guess, false advertising, but because the hypotenuse is always the bigger measurement, that's what they use. That's what they use, so because they think a bigger number certainly looks better when advertising. All right? However, in this case here, the first TV is a standard 4:3 television set. And so what that means, that is the ratio of the two sides. It looks like the width might be a little bit more than the height, so that would be the 4, the height would be the 3. That's the ratio of those sides. Okay? And then the other one, the widescreen, is a 16 to 9. Again, that's the ratio of those sides. To help them decide, we want to calculate the actual screen dimensions, right? This isn't the dimensions, the 4:3 and the 16:9. It just shows how those two sides are related, but it's not the actual dimensions. So we're going to calculate the actual screen dimensions for each, and then see which one has the actual viewing area that's greater. So here's how this would be done, okay? Instead of just 3 to 4, I'm going to go 3x to 4x. And then I'm going to write a relationship involving Pythagorean theorem to let us solve for x. And then once we have that, we can actually find the dimensions of this TV. And then we'll do the same thing for the second screen. But starting with this one here, the hypotenuse is 32 inches long. So therefore, 3x all squared plus 4x all squared has to equal 32 squared. I'm just using Pythagorean theorem. When you square 3, you're going to get 9, and when you square x, you're going to get x squared. When you square 4, you'll get 16, and when you square x again, you'll get x squared. The right side, you have to square 32. And that gives us 1,024. We can solve for x. We'd start by first adding the 9 and 16 together. Those are like terms. That'll give us 25. X squared equals 1,024. We can divide both sides by 25 to get x squared by itself. So the 1024 divided by 25, x squared equals 40.96. And then we'll take the square root of both sides to find out what x is. So square root of that number, x is exactly 6.4. So using this and the fact that the ratio of the sides for this TV screen are 3 to 4, I let them be 3x and 4x. I now know that x is 6.4. So the height of this TV would be 3 times 6.4. The width of the TV would be 4 times 6.4. So I'm going to multiply this by 3 and get 19.2. And that would be in inches because the hypotenuse is in inches. And the width will be 4 times 6.4, which is 25.6 inches. And then the area is found by multiplying these two together. And this will give us the viewing area of this television. 25.6 times 19.2 is 491.52 inches squared. Area is always in units squared. So that's the viewing area of that television. And now we need to do the same thing for the second television. Exactly the same process. So the ratio of the sides is 9 to 16. I'll let them both be 9x and 16x. And we'll use Pythagorean theorem to find out what x is. Again, both TVs have a hypotenuse of 32 inches. When you square 9, you'll get 81x squared. Plus, when you square 16, you'll get 256x squared. And on the right side, you're squaring 32 again, which we already know is 1024. So again, I just want to check. 16 squared is 256. Yep. So you're going to add 256 and 81 together. That gives us 337x squareds. We need to solve for x like we did before. Divide both sides by what's in front of the x squared. In this case, that's 337. So 1024 divided by, divided by 337 is a decimal, which we'll round to write down, but we'll keep that in our calculator. That's what x squared is, approximately 3.0386. And then we'll take the square root of both sides to get x. X is approximately 1.74. Okay, I'm going to store that number into memory because it's a irrational number. So I'm going to store it into memory slot A because I need to take that number and multiply it by both 9 and 16. So the height of this TV will be 9 times that 1.74. So I'm going to multiply that by 9. So it's approximately 15.69 inches. And I'm going to store this into memory slot B, because when I find the actual height and length, remember, I need to multiply them together to get area. So it's there for the next time I need it. The width of this TV is 16 times that 1.74 inches. So 16 times the number we put in alpha A is 27.89 inches, approximately. And then our area is found again by multiplying these two together. But I'm going to use the entire numbers that are in the calculator, not the rounded ones. So I've already got that 27.89, that entire decimal there. I'll multiply by alpha B, which is the height that I stored in there, which gives us 437.55 square inches. Which is less than the other one. So if you look at those two screens, I think most people would look at that and say, well, I think that the widescreen one has a bigger viewing area. Turns out it doesn't. Turns out the standard screen has a bigger viewing area. Okay? So the your turn is the same type of question. We're not going to, the only thing that's different is that the hypotenuse is 46 inches instead of 32. So we're not going to take any time to do that. Let's look at example 3. Alison wants to make a drum that resembles the one used by a drum dancer in Iqaluit, Nunavut. He has a circular frame over which to stretch the caribou skin. Then he will lash it into place along the frame with sinew. He uses about 3.5 inches of sinew for each inch on the frame. So the frame is circular. Okay, so if we just maybe draw, this is where the frame is. It is circular. So for every inch along here, every inch along the circumference, it takes 3.5 inches of sinew because it's wrapped around the skin and the frame. So for every inch along the circumference, it takes 3.5 inches of sinew. We're asked to estimate the diameter of the drum in imperial units and use the scale of 1 to 15. And then we'll estimate how much sinew he needs to make this drum. So, once again, we need to grab the ruler. And we need to use it to measure the diameter of this drum. So, it looks like it is 1 and 1, 2, 3, 4, 5/16 of an inch. That's what we get. 1 and 5/16 of an inch. So for part A, 1 and 5/16 of an inch is the diameter of the drum. Which, if we write that as an improper fraction, 16 times 1 is 16, plus 5 is 21 over 16 inches. 21 over 16. We're told that the scale is 1 to 15, so we'll multiply by 15 over 1. In this case, we can't simplify because 16 and 15 are not divisible by the same number, so we multiply. 21 times 15 on the top is 315 over 16 of an inch. We can see what that is as a decimal. So 19.6875 inches. And we can convert that into feet and inches by dividing by 12. So it's 1 foot and 0.640625 of a foot. 1.640625 feet. So that's 1 foot. And if we take away the 1 foot from that number, that's the portion of the foot that's left. Multiply that by 12 for inches. So and round to the nearest inch, approximately 1 foot 8 inches is the diameter. Now, how much sinew does he need to make the drum? And it's going to be a larger number because it says express this in yards and inches. As we said, it takes 3.5 inches of sinew for every inch along the circumference. So we need to find out what the circumference of the drum is. And yesterday we saw there are two formulas for circumference. One involving radius, that's 2 pi r. One involving diameter, which is pi times d the diameter. That's what I'm going to use because we have that number. We have the number. The diameter is, and I'm going to use this 1.604625 feet for the diameter. So it'll be pi times 1.640625 feet. So back to the calculator I go, where that number came from. I had 19.6875 inches that I divided by 12 to convert it into feet. Did I copy that down? 19.9875 divided by 12. I just want to check this. That came from 35 or 315 over 16. So that was inches, and then we divided it by 12 to put it into feet. 1.604. I reverse these. 640,625. What's that? I did. 19.6875. That's what I have there. I'm looking at my calculator. I went 315 over 16, which is 19.6875. That's what I have on my calculator. 315 over 16. Where do you see 9875? It says 6875. But I'm not using this. I typed it in wrong there, but I'm not using that. I'm using this right here, which is correct. So it's 1.640625. So that is right. And that's multiplied by pi. So there's the circumference of that drum in feet. 5.15 feet, approximately. Now we are going to have to go back and convert this into inches though, because we were told that it takes 3.5 inches of sinew for every inch along the circumference. So we are going to have to convert this into inches by multiplying that by 12. That's how many inches the circumference is. 61.85 inches. And again, that's rounded, but that's okay because we're going to keep that in our calculator. We are told that it takes 3.5 inches of sinew for every inch along the circumference. So now we take that last number we got, the 61.85, and multiply that by 3.5. And so there's the length of sinew that will be required in inches, 216.48 approximately. But we're asked to write that in yards and inches. And we saw earlier, and it's on your formula sheet, there are 36 inches in a yard. So if we divide this by 36, it's 6 yards, and then this portion is the portion of the yard that's left. So 6.013 yards. 6.013 yards. And there's no symbol for yards except YDS, but no little mark that we can use. So again, we're asked to convert this into yards and inches. So it's 6 yards. To get the inches, we'll take away the 6. And remember, there are 36 inches in a yard, so we'll multiply this by 36. And it's less than an inch. Okay? It's less than an inch. So we'll just say approximately 6 yards. That's how much sinew would be required. All right. We're going to stop there. So what you should be working on is page 31 to 34. Questions 7, 9 through 11, 13, and 14. You're going to want to copy this down before I shut it off. Nope, this is not due for marks, but we've only got one lesson left in this chapter, which we'll be doing tomorrow, and that's converting between the two systems. And that means on Tuesday, you're going to have a quiz on this chapter. We're going to be done this chapter tomorrow. So quiz on Tuesday on this stuff. Okay? Go ahead. Just give me a second, please. So again, there's the questions. I will post the solutions to Google Classroom so you can check your answers on.